Welcome to On the Road with Bill Holub podcast.
Hi, this is Bill Holub from Steam Trap Survey, LLC. Today we're going to talk about open blowdown valves. Blowdown valves that are left open. But first, let's introduce Jessie.
Hi, I'm Jessica from Branding with Jessie. I do all of Steam Trap Survey LLC's media, including but not limited to social media marketing and management, podcast production, and video editing. Why are blowdown valves often left open, and what are the operators trying to accomplish by opening valves?
Blowdown valve might be left open for a couple reasons. One, startup. That's where possibly condensate collects during shutdown, and personnel will open up that blowdown valve to drain that excess of condensate to the ground, and then hopefully close it back up so that they can run efficiently. But sometimes it's left open. Another situation where a blowdown valve could be left open is an undersized steam trap. The only way you're going to get that condensate out with an undersized steam trap is getting it out before the steam trap, and that's opening a blowdown valve. So that could be resolved pretty easily. During installation of steam traps or valves or whatever, depressurizing the steam line could be an open blowdown valve to allow that steam pressure to escape before you can start repairing whatever you're repairing. So during startup, you want to make sure that ball valve is closed again. Another situation would be a stall condition. These are common when you run into a control valve, maybe controlling a heat exchanger or controlling air handler unit. And as that temperature of the product, whether it's air or whether it's water or whatever it is that you're heating, gets to the temperature you want it to be, that control valve starts closing. And when that control valve starts closing, that steam pressure that the control valve is allowing to heat the product is being reduced. And if it's reduced lower than what you need to push the condensate out through that trap, that's considered stall condition. So for instance, if you have a 20-foot lift after the steam trap and that control valve drops down to below a 10 psi pressure going into whatever you're heating, heat exchanger, or air coil, then you're going to run into a stall condition.
Is it necessary to do so, or is there another way?
One is education. Educate your personnel on how to efficiently use your steam. Open ball valves, not a good way to do it. You want that steam to collapse back into condensate in the process, not on the floor or not into the atmosphere. Properly sized steam trap helps. If you suspect a steam trap that is undersized, evaluate everything, resize it, reinstall a new steam trap that's properly sized. If you run into a stall condition, it does not matter how many traps you put on, what size trap you put there, it's just not going to work. So what is commonly used is a steam pump. Steam pump is basically a big float trap that will get rid of all your condensate using your high pressure steam. So it's independent of your control valve steam. Your control valve can go down to 10 psi. Well, maybe you have 100 psi in your main steam line, so your main steam line is going to supply that steam pump so that when that pump says, let's drain this condensate, the valve opens up using that high pressure steam and it can push it back to wherever it needs to go. There's going to be a short video explaining this a little bit to follow right now. Thank you very much.
Open blowdown valve. Blowdown valves are often left open. This may be done to compensate for failed or undersized steam traps or heat exchanger stall. It may also be the result of operators opening valves to bleed off excessive air or condensate during startup and then leaving them open.
Thank you for joining us. Look forward to our next podcast.